Hello folks, this is Mr. Walker coming to you with your next round of notes. So, we talked about area 2D figures, but what happens when we start mixing some of these together? Today, we're going to be talking about composite figures. So, composite figures are a two-dimensional figure that could be divided into more than one simple shapes. So, when we talk about simple shapes, we're looking at taking a shape like the one that we're seeing here, and breaking it up into the smaller things that we are seeing inside of it. Now, what do we do when we do this? We're trying to find still the area, so all the properties that these shapes have are still going to come into play. So let's go through and analyze this quick example. To find the area of a composite figure, we first use dotted lines to separate the figure into familiar, non-overlapping shapes. So this is not a case where we want to go through and see the shapes overlap. We want to make sure that the stuff is going to, in fact, work over time. So, over here, what we're seeing, I see this curve on one side. I see this little edge over on the right side. So that means that we can probably split this up into a rectangle, a semicircle, and a triangle. Let's go through and take a look at it. So this right here, this is a semicircle. In the middle, it looks like we got ourselves a rectangle, and then to the right, a triangle. Now, as we go through this, we have to remember a couple of things. This shape has a few bits of information here. This, if you remember from back when we were doing circles, this is a radius, so we're just going to label that as R. All of our radii in a semicircle, circle, whatever, are the same length. So this, and this are all radii. Now, around the shape, you're going to notice that there's a few measurements that they give us. What we're going to do is we're going to calculate the measurements that each of these shapes will have. So, first for our friend over here, the semicircle, this has a radius of 5. And you might be wondering, how did I go from 5 to having this other dotted line be 10? Remember, all three of these lines are the same length. So if they're the same length, that means that if this is 5, this and this are both also 5, which is how we would say that this is 10. Now, we got everything that we're going to need here. So our next step is we're going to find the formulas for each of these shapes, and we're going to calculate them. So let's deal with some areas. First, we got our triangle to the right. It's 1/2 base times height. Our base for this is 6. Our height is 10. So 6 times 10 divided in half gives us 30. Next, we go through, let's take a look at this rectangle in the center. We have our base times height. This is 12 times 10, which is 120. And then we have over here, this isn't just a circle, it's a semicircle. So that is about half the area of a circle, 1/2 pi r squared. Remember, we're still using 3.14 for pi, so just make sure you keep that in mind. 1/2 of 3.14 times 5 squared gives us 39.3. Our final step for this is we add all the areas of these individual shapes up together to represent the whole area. So when we add all three of these together, we get a final area of 189.3. So we're just going through and breaking up the shape into smaller shapes. And then we are going to calculate those areas and then put them together. Now, along with this, we have one more bit of notes that we got to go through. So what we're going to talk about is a bounded region. So a bounded region is a space created by graphs of functions on the coordinate plane. So over here in our example, we have 1, 2, 3, 4 different functions here. Y equals 4, y equals -2, y equals 2x plus 6, and y equals -3/2 x plus 7. all four of these, when we go through this, we're going to first graph them. So let's graph them. So we got this line here and this line here. These are two lines that are at 4 and -2. Remember what we talked about back with parallel lines. These guys have the same slope of 0. So these two are parallel, just as a reminder. Then over here, we got this diagonal line coming up with y equals 2x plus 6, and then this one with y equals -3/2 plus 7. Now, when we look at a bounded region, it's created by these functions. So, what area would you want to go through and deal with? You want to deal with the shape that is connected with all four lines that we made. So, let's go through and shade that in. Now that we have this shape, our next thing is we're going to use the area formulas that we have so that we can find the area of this region. But which area formula do we use? We look at these lines and then we determine what type of shape is made. Remember what I said earlier, that first two lines that we had, here and here, these guys are parallel. Because they're parallel, this makes this and this the same slope. And these two guys, we could tell they're not the same slope because they're not going the same way. They end up intersecting. So this is a trapezoid. So now that we're here, let's go through and handle some info. Let's see what we can go through today. Alright, first, we have on a trapezoid, base 1 and base 2. Base 1 up here looks like it's about 1, 2, 3. So this is going to be, I'm going to label that as 3. And then over here we got another base, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this base here is 10. Now that I have my bases, next thing I want to do is I want to look at my height. I could find my height actually by seeing how far these two are from each other. This guy's at 4, this guy is at 6. So that means that the height for this is 6. Wait, did I say 4 and 6? I mean 4 and -2. My fault. Alright, so we're calculating the area of this trapezoid. That gives us 1/2 base 1 times base 2. Base 1 is 3, base 2 is 10, and then we multiply that times the height 6 and take half of that, and that gives us 39. So, if they give you multiple lines and they want you to make a bounded region, graph those lines, and then we have to make our shape from there. Alright, let's get into some examples, people. Go ahead and pause it and come back and see if you were able to do this correctly. Alright, people, hopefully you went through and copied this down and did this correctly. Let's go through and deal with some of this info. First thing we got this composite figure, so let's go through and blank this up. I see that this shape here, it's not looking like all four of these sides are parallel, but I could definitely think that these two are, because they're not touching. So a four-sided shape with one pair of parallel sides, this is a trapezoid. Now along with this, let's remember a couple of things. This line here, this dotted line, corresponds with this line down here. So we're going to label this as 22 just to make sure we remember it. And if this whole space from here to here is 110, that means that when I cut off at this dotted line where it says 32, we just got to go through and have this be 110 minus 32. Alright, let's find our areas, folks. First, we got our area of that triangle up top. So that's 1/2 32 times 22. That gives us 352. And then we find our area for that trapezoid. So 1/2 22 times 50 plus 78, which gives us 1,408. And then we add them together. When we add them together, we get a total area of 1,760. So take your time. It'll be okay. You just have to understand the things that we're seeing so that they make a little more sense for you. Okay, next one here. We got another dotted line, but let's go through and finesse out some information at this time. Remember, you see these marks here? That lets you know that these sides are the same. So this side is also 7. So what is this little part in the middle? This whole length from this tip to this tip is 18 feet. So 7 plus 7 gives me 14. So that means that this dotted line here is going to be 18 minus that 14. Next thing, this is a triangle here. We also need the height. So the height is everything from after we get to the tip of here, because this is where 9 is. So we have to go from 9 to the end of this. So this length here is 21 minus 9. So now that we have the information, let's go through and solve this. First, we got the area of our triangle. When we calculated that stuff, that height was 12. When we did that, 21 minus 9. So 1/2 of 18 times 12 gives us 108 for the total area for that triangle. Then below, we have us a little rectangle. That's just base times height. So 4 times 9. And then when we add those together, we get a total area of 144. So just take the information that they give you, try to break it up as much as you can so you can use it. If you feel any type of way, remember, it's the first time we're doing this. You've seen it maybe once or twice in middle school. So don't feel any type of way. It's been about 3 years. Alright, now we got 2 more composite figures that are being made over here. And then we got a bounded region over there on the coordinate plane. So let's go through and deal with these. Looks like we got ourselves a semicircle once again. So let's go through and deal with our radius to start off with. When we look at our radius, that is coming from here, the center, up to the edge. And I can tell that from the tip of this triangle to where that dotted line starts is 5. So this right here is what I get when I take 8 and I subtract 5. Then I need to know that this and this and this, these are all radii of the circle. So that means that these guys are the same lengths as this that we're going to find in the middle. So let's deal with that in the middle. 8 minus 5, that's 3. And if that's 3 up here, that means this and this are both going to make a 6 at the bottom. So let's do some calculations. Oh, I didn't even realize it was going to pop up. Alright, so once again, we got this 3 from doing 8 minus 5. Ooh, my 8s are looking even rougher than usual. Yeesh, people. Sorry about that. 8 minus 5. Perfect. Alright, now that's 8 minus 5 giving us that 3. Let's go through and calculate this. Remember we said earlier this is part of those 2 radii making a diameter. That's where this 6 comes from. So we got 1/2 6 times 5, which is 15. Then we got to find the area of the semicircle. So 1/2 pi r squared. So 1/2 of 3.14 times 3 squared gives us 14.1. We add those together, we're going to get 29.1. Alright, home stretch, people. Let's get this last one done. And then hopefully y'all go off to y'all weekend having some fun. We got this bounded area, so let's go through and graph these lines. 2 of these are diagonal, so we got 1, 2, and then we got a horizontal one down here. Alright. Now, first, let's shade in some stuff, and let's go through and deal with our information. For our height, it comes from here down here. I can tell where this is. This is those y-intercepts for these 2. So how far this is what we get when we go from 5 minus -2. Sorry about that, folks. Just had to go through and cough. Now, at the bottom here, I have to go through and count this base. So that's 1 box, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this whole box down here from here to here, this base is 14. Now that we know this, what shape does this obviously look like? Looks like a triangle. Let's deal with it. 1/2 base times height, so 1/2 of 14 times 7 gives us 49, folks. Appreciate y'all for making sure that you work with me. Remember to go through and get your notes glued into y'all book. And have a good weekend. See ya.